Okay, I think we're live with the Low Carbon Hub webinar this evening. If people are on, please do put your name into the chat channel so that we can see that you're there and say hello. My name's Barbara Hammond. I'm from the Low Carbon Hub. I'm the CEO of the Low Carbon Hub, and I'll be running, well, I shouldn't say running, I will say chairing the webinar tonight. Okay, so I'm going to kick off with the introduction, but please do, hi David, sign into the, oh, and Eleanor, fantastic, hi Eleanor. And Tim, fantastic, oh great, you've got going. I'll get on with the introduction as you write into the chat channel, thank you. So hello everyone, we're really getting into the swing of things with our webinars at the Low Carbon Hub and finding them a really good way of keeping in contact with people and getting some interesting stuff discussed, not quite during lockdown anymore, but during COVID. Thank you very much to everyone for joining us. I hope you're not feeling too hot. I'm feeling a bit steamy myself. In case anybody isn't aware of us, oh blimey, we've got people from York Community Energy, Scott, and somebody from Norway. Hi, Tom Gilb from Norway. Amazing. And Dave Green from Shropshire. Excellent. Okay, so for those of you who don't know the Low Carbon Hub, we're an Oxfordshire-based social enterprise that's out to prove that we can meet the UK's energy needs in a way that's good for people as well as for the planet. This is the fourth in our series of webinars, which are all focusing on the future of energy and the transition to a zero carbon future, renewable energy future. This one has a particular focus on our Project Leo. For those of you who don't already know, Project Leo, Local Energy Oxfordshire, is a £40 million project conducting real-world trials to understand the role local energy can play in accelerating the transition to a zero carbon energy system. Last week, we hosted a community coffee morning. It's amazing all of these innovations coming through on Zoom. And we had low carbon community groups from right across the UK, which is very exciting. We had an excellent turnout, but if you missed that or any of our previous webinars, all of the recordings are on the Low Carbon Hub's YouTube channel. And just to remind everybody that we are recording the webinar tonight. So that doesn't mean we're recording chat, so you can say what you like on chat. Scott is here as our willing victim who is willing to be recorded for future posterity. For those of you who are signed up to our ground mount solar webinar later this week, we've had to postpone that. We're really sorry about that, and we'll reschedule that as soon as we can. We're working on a series of webinars for July, and we've got penciled in at the moment topics such as people and the energy system. We're hoping to get the wonderful Sarah Darby from the ECI on that. The role of flexibility in a net zero energy system, and if that is gobbledygook to you, then you probably need to join that webinar to find out what it means. So when we finalise those details, the registration links will be available on our website, www.lowcarbonhub.org, in the news section or in the events bit of our Facebook page. So all of that preamble over and done with. Few more people from Chichester. Wantage, hi Alan from Wantage. Fantastic. So I'm delighted to introduce our topic for this evening, Project Leo's Smart and Fair Neighbourhood Trials, brackets so far, close brackets. And I'm really delighted to introduce our speaker, Scot Wheeler. Scott is a researcher in the engineering the Engineering Science Department of the University of Oxford, and Fellow of the Oxford Martin Programme on Integrating Renewable Energy. Scott's research focuses on the role of smart local energy systems in the transition to a low carbon energy future. And that includes the integration of new flexible energy technologies, innovative market structures and user engagement at a local level. I first met Scott when he was employed by Professor Malcolm McCulloch to be the researcher on our Oxfutures European Regional Development Fund programme that was one of the catalysts to Project Leo. So it's very exciting to see Scott become an absolute sort of central pillar of the Project Leo programme. Scott, as part of that, is coordinating the project's agile approach to flexibility trials and consolidating the technical learnings. And I think you'll see a really innovative approach to what we're doing as Scott goes through his presentation. Scott is happy to take questions during the talk, and we've got 2 spaces in the talk where we'll be doing that. I'll be monitoring the chat channel, and if there are any questions I can answer before Scott gets to those slides, I will. So please keep the questions coming. That's my intro over and done with. Scott, over to you.
Okay, thank you, Barbara, and thank you for the opportunity to speak as part of the webinar series that you've been putting on at the Hub. And hello to everyone that's tuned in. So as Barbara said, I'm Scot Wheeler. I'm in engineering science in the Energy and Power Group. And I've been working on Project Leo for the last year since the project started.
I think Zoe has to move it on. Yeah.
I think that's okay. You can see the next slide with some
yes.
lovely faces on. Yes. So I think I'm the 4th in the webinar series, which all of which have kind of touched on Project Leo. Hopefully, if you haven't tuned in, then I'll provide enough background on Project Leo, and you might see some familiar slides if you have tuned in. But hopefully I'll introduce some new things along the way and dive deeper into some of the trials that we've been putting on. I thought I'd start with essentially the take-home message that I wanted to put across today, and this is all around minimum viable systems. And I think this phrase has been mentioned a couple of times by Mel and Malcolm previously, and I just wanted to put a definition out first off. So we see the minimum viable system as a trial which represents the minimum stress set of participants or processes which are required to test a new modification or asset use case or service. The whole idea about this is testing new value and identifying new value at a small, fast scale before significant investment in time, money, or user relations are committed. The other thing that I wanted to put across was there's actually a lot of value in learning by doing, and that's an approach that we're definitely taking within Project Leo. So a quick overview of the talk. So I'll start off just by introducing smart local energy systems and why they're interesting for the Oxfordshire context. I'll then introduce the lean ecosystem transition approach, which we're using within Leo, and the minimum viable system as well. I'll then take a deeper dive into the trials that we've run so far, and these have been based at the Oxford Bus Company, at Sanford Hydro, and one which we call Oxford Behind the Meter. And then finally, I'll just summarise some of what's coming in the next year or so with Leo, and how we move forward with these MVSs. So for those that aren't familiar with Project Leo, it's, like Barbara said, a £40 million trial to innovate within the space of local energy systems. And the objective of Leo is to develop a new local flexibility and energy markets which maximise the asset utilisation and enable innovative business models for investment in a low carbon energy future. Project Leo is running in parallel to another project called Transition, which Mel introduced last week, which is run by SSEM. And they are really developing the market facilitation platform which Leo plugs into. And Leo is kind of the Oxfordshire-based real-world trials which plug into Transition. So within LEO, we have a number of different levels, which you can see on the diagram on the left, from the flexibility exchange, which actually communicates directly with the DSO. We then have technology platforms and service providers, such as the Low Carbon Hub, or Nuve with electric vehicles and EDF Energy. Below that, we actually have the energy resources themselves, and that can be buildings, batteries, PV generation. We also have the energy citizens as well, so the users of the energy system and how they can change their behavior. Finally, we then have a framework of learning from both a technical point of view and a social point of view, which then feeds into dissemination strategy, and that's largely led by the academic institutions and the local authority. So what is a smart local energy system? Well, it's quite a new phrase, and there's lots of definitions, and I'm going to avoid setting one out for you now, but there's a lot of work currently undergoing in Energy Rev, which is a consortium of academics which work in parallel to the innovation demonstrator projects. And they're really looking at this kind of definition of what smart, what local, what energy system actually means. But I thought I'd just highlight some of the drivers of why we might look at smart local energy systems. And I've kind of categorized them into three different themes. So one is financial. And one of the drivers for local energy systems is that tech is becoming more affordable to actually to have at a local level. There's the potential to save on your energy bills and look at new energy trading mechanisms such as peer-to-peer trading. And it is also able to support the local economy. We also have social and environmental drivers, and these are largely around reduced local emissions or even community cohesion. And then finally, we have technical drivers as well. So we have, essentially, we're generating energy where we want to use the energy. So we have reduced losses on the transmission and distribution networks. We also can have increased network resilience, as well as higher utilization as well, which enables you to do many of the other things by investing in more local energy. So I thought I'd use an Airbnb analogy, which I think I'm actually stealing from a colleague of mine, Thomas Morstan. And here is a graphic of hotels in New York. And what you can see is that they're quite condensed within the Manhattan area, which is where much of the tourism is focused within New York. But then because of digitalization and digital platforms, Airbnb came along and disrupted this system of hotels within New York. And what you see is, if you plot where Airbnbs are across the city, then the first thing you notice is how diverse and distributed Airbnb is across the city. Now, this has led to higher utilization within the city, which is quite constrained in terms of accommodation. And so there are fewer empty rooms. So before, you would have empty rooms within your flat, which you can now rent out to tourists through Airbnb. And this has given new value streams to the owners of that accommodation. We also have this idea of equity. So we now have an increased supply and a variety of rentals which tourists can choose from. And so you can really tailor your experience and your tourism experience within a particular area, and thanks to Airbnb. Finally, there's this concept of local co-benefits and additional local economic and social value. So what you'll notice is, because accommodation is now so distributed across the city, you're actually getting tourists that are going to different areas within the city, spending money in local businesses and improving the economy of those local areas. So how does this relate to the energy system? Well, if we look at Oxfordshire, on the left-hand picture here is the generation which was in Oxfordshire in 2000. And I think there's perhaps 5 small dots there, and then one large dot, which is essentially, that's Didcot A, which was a coal-fired power station, which generated about the same amount of energy which was consumed for Oxfordshire. Since then, we've seen this radical transformation of the energy system, and a lot of renewable generation, which is installed at a local, low voltage level. And this is, you can see this in the center image, which is a screenshot from the People's Power Station, which I know the Low Carbon Hub are heavily involved with. And this is a platform where people that have distributed energy resources can kind of advertise where they are and the performance and how much they're generating. And what's actually surprising is this is only a subset of that distributed energy resource. So if you look at the feed-in tariff and renewable obligation registered assets, there's actually in excess of 9,000 within the Oxfordshire area. So we've got this huge amount of distributed energy resources, which we want to make use of. So how does this kind of help Oxfordshire move forward? Well, if we look at our 2030 carbon targets, then which are somewhat already out of date. I think they were set in 2018, 2016. We need to get to around 58% of our electricity from renewables and 40% of heat. Now, in order to do that, because we have kind of demand growth from electrification of heat and transport, we need to get to, we need an extra 2 gigawatts of additional generation, renewable generation. And for Oxfordshire, that's largely going to be based around solar, and that's actually 6 times the current capacity. So we already have 9,000. You can imagine how many distributed energy assets we might end up with by 2030. Now, a problem that you have with renewable generation, and particularly solar, is you can't control when the sun shines. And so you have this variability both throughout the year and intraday as well. And so we have to think about how do we cope with this variability, and we need balancing. And for anyone that watched Malcolm's talk a couple of weeks ago, he talked about kind of what balancing is needed and how much and what our options are there. But all of this can be essentially enabled by digitalization. And hopefully, or what we hope is that through digitalization and data and communications between these different assets, we're able to maximize the utilization of all of these assets and of the network at the lowest possible cost. So the approach that we're taking within LEO is this agile lean approach, which was first developed by Eric Ries, and anyone that kind of works in any digital industry has probably come across the lean approach. And we've kind of tried to develop this slightly for not just the development of a product, but actually for a much wider system transition. So we start off by identifying a societal need. That then inspires some sort of hypothesis or theory of change for disrupting the current system. From that hypothesis, we're then able to build this concept of a minimum viable system. And so this again is a minimum stress set of kind of participants or processes in order to prove our hypothesis right or wrong. And within this idea of a minimum viable system, we might have lots of minimum viable products. So that could be the Low Carbon Hub developing some solar asset, or PICLO developing the integration platform between the DSO and the assets. And so, and all of these can kind of iterate and innovate within their own small cycles, and they feed into this much wider system that we're looking at. From that minimum viable system trial, we're then able to measure against certain processes and KPIs, which enable us to do some learning, to see what worked, what didn't work. And we might, from that, want to adapt our hypothesis or theory of change to better suit the societal need. Or we might actually understand more about our societal need that we came up with in the first place. So perhaps we were wrong about what we actually thought people wanted. And so we can make a much larger shift. And the idea is that we iterate through this loop over and over again until we develop a system which hopefully works for everyone. So about a year ago at the Leo Inception workshop, we came up with these three overarching societal kind of goals or vision for Leo. And I just wanted to kind of highlight actually how similar these appear to what Airbnb achieved. And so first off, we came up with this concept of a local balanced net zero energy system. And this is all about how we best utilize the assets and the network that we have in Oxfordshire. The second one was about reducing inequalities, and this is the ability to afford energy to meet all needs. And this is all about equity and building an equitable energy system. Number three was all about positive ecosystem benefits, and that's CO2 and beyond. So again, this is those local co-benefits that we were talking about earlier. That could be reduction in CO2 emissions, but also betterment of the local economy, and kind of all different kind of local co-benefits. So next we move on to the hypothesis, and this is something that we're working on in this concept of a theory of change within Leo. And it must have been the hot weather that inspired this kind of horizontal ice cream diagram, which became quite popular. Working from kind of left to right, we have this kind of top-down approach where we start off at a very high project level. And so here we have this idea of a flexibility market as a way to kind of create new value for all of these different assets. At the next level down, we then start to think about different types of service which will be offered within that flexibility market. And we have three main ones here: DSO procured services, DSO enabled services, and market services. Below that, we expand slightly more and we actually think about the specific services that have been identified. And within the transition project and working with the Leo project, we've identified four main services which are going to be trialed within Leo, and they're the top four that you see there. So the first one is constraint management. The next one is peak management. So this is about kind of flattening net demand. The next one is offsetting. This is kind of about if one person turns down generation so that somebody else can turn up generation. Overall, you have zero net change.
Scott, I had a question which I'm just going to slot in because it's a fairly fundamental one. Not everybody knows what a DSO is.
Right, okay, yeah. So DSO is, so I would encourage you to watch Mel's talk, which he gave a couple of weeks ago, which looked at the DNO to DSO transition. So a DNO, which stands for Distribution Network Operator, is the organization that owns and manages the electricity distribution network within an area. So this is SSEN, who is the lead partner of Project Leo for Oxfordshire. And they are being encouraged to transition to what is being called a distribution system operator. And this is an organization which might come from the DNO, or it might actually be a separate organization. But their role is to take a much more active role in the management of energy on that network. So they might be procuring flexibility in order to manage supply and demand at a local level. Up until now, that's mainly been managed at a national level by National Grid. But as we get more and more assets on the local network, then that needs to be done at a much more local level. So that's why distribution network operators are having to understand this potential new role of system operator.
And I think the key thing, Scott, isn't it, is that the role is the neutral market facilitator, so that they're sort of stepping out of any commercial conflict that they might have there, which is a sort of interesting transition in itself.
Yes, yeah, so they would be a regulated business and they would have to be neutral in such a market. Yeah. Okay, so I just mentioned the last one, which is being tried within Leo, and that's this exceeding MEC, which is your maximum export capacity or minimum import capacity. And I'll highlight where this might be interesting later on, but this is very much about kind of trading capacity, which has been assigned to particular assets, if you're capable of, say, generating more. So the next level down, we then have these MVS categories, which again, I'll go into more detail in a second. But here we've identified 5 within LEO that we're starting off with, and this is the concept of a prosumer, so someone with some sort of distributed energy asset. We then have generation or a generator. This is someone that has flexible generation. We then have smart neighborhoods, and this is about coordinating multi parties and multi-sites. We then have aggregation, which is actually the development of aggregator platforms. And finally, portfolios, which is about how you manage a diverse portfolio in order to for the benefit of the network. Finally, we have the actual MVS trials themselves, and we try to organize our learning into technical, commercial, and social, and then finally regulation and government streams. And these can be quite low-level questions that we're asking in low-level learning, such as kind of what metering do we need on assets? What communications do we need between assets? What contracts do we need in order to develop? And the kind of the cost of the service, etc. So we have 3 different types of MVS within LEO. The first one, MVS A, is all around operation, and this is where I'll talk most of the time today, and this is all around the actual delivery of flexibility services. But we also have 2 other types, one which is around planning, and this is kind of future system planning. So how do you plan your energy system in line with kind of Oxfordshire's kind of sustainable growth strategy? So how do you take a kind of a 10-year view of how the energy system is going to change? And then the third one is around policy and regulation. So how do you take the learnings from LEO? How do you replicate LEO? And how do you scale LEO by kind of informing and changing the policy and regulation which is needed for these types of local energy markets? So I was going to pause there for any questions that have come through, Barbara.
So we had the question that I've been attempting to give some answers to in a fairly unformed way about whether the distribution service system operator could be in any way partially or wholly owned by the community.
Ooh, good question. I think at the moment it's the definition of exactly what a distribution system operator is or does is still quite open. I think it's easiest to think of how you transition from a kind of DNO to DSO because they have the best knowledge of the network and how the network works, and in theory they should be able to stay impartial, but there is possibilities that other organizations might be able to take the role of a DSO, but I think SSEN would probably be the best person to answer that.
Yeah, and Peter Spark is reminding us all that in Germany they do actually operate a system of community ownership of DNO DSOs, and they have, as I understand it, a sort of a tendering process every 5 years I think there are smaller areas that are covered by these systems in Germany than they are in the UK, but it's a really interesting question. The other thing that I think we'll be wondering about as we get into the smart and fair neighbourhood trials, Scott, is the question of what local management could or should be to get that sort of long-term collaboration on how to accommodate new development in the grid, how to make the transition, particularly in areas like EV and transport more broadly.
Yeah, I definitely agree.
And also, I think the link to neighbourhood planning is quite an interesting one as well, where we've already got the sort of community layer of producing plans. How do you make the link between the planning system and the energy system is an interesting one too.
Yeah, and Oxfordshire has a lot of growth planned for the next 10 years, so there's plenty of opportunity to think about that some more.
Yeah, and we've got another question from Tom Broughton about the driver for the future 2030 renewable target, how it's broken down into smaller agile targets. And I think an answer that I would give to that question is that that's one of the things that we're going to be thinking about through LEO, because as you said in your intro, Scott, the energy strategy for Oxfordshire that was only published last year is already out of date. And so, you know, there's quick agile work that needs to be done to sort out what we're going to do where across the county.
Yeah, definitely. And that's why this agile approach within the energy system, I think, is so attractive, because it is a system which is changing really rapidly, and you might argue not quick enough, but also it can become very hard to develop long-term business models in kind of such a changing market. And so that's really why we're trying to take this agile approach in order to kind of mitigate against that.
Yeah, and one of the things that I'm finding really fascinating in thinking through all of this is the realization of that we've got sort of different layers of mapping with the primary substations and how they do or don't map onto existing administrative areas like parishes, and how those do or don't map onto ward boundaries for local councillors and all of that sort of thing. It's a really interesting little nuggety problem, that.
Yeah, in a way, we're quite lucky with Oxfordshire in that it aligns quite well with actually a distribution area. So with SSEN, there are some parts of the country where within one town you're actually fed by potentially 3 different DNOs. And I just kind of highlight actually, so again, Energy Rev have done quite a lot of work actually in understanding what that word local means, and how you define local. Is it a geographic area? Is it a network area? Is it essentially just what is the feeling of a community, which might not actually align with even a council area, for instance?
Yeah, absolutely. You know, that's going to be quite an interesting question, especially given that the existing administrative structures like parishes at the most local level or even district councils don't have a lot of expertise in these areas as things stand. And we've had another comment from Alan Barlow about the local electricity bill effect on community supply. And that's going to be an interesting one to see how it develops as well. That's a 10-minute private members bill, and just sort of like 2 sides of Ofgem will make it so that local electricity can be traded locally. It really needs the government, I think, to pick that one up and run with it if it's going to happen. Yeah. But Leo can feed into the thinking, hopefully. And then Eleanor Watts from Rose Hill has said, you mentioned community cohesion as a driver. How do you envision engaging people in a smart energy neighbourhood when they're preoccupied with money problems and renewable energy isn't their immediate preoccupation?
That is an extremely good question, and as the engineer, I'm probably the wrong person to answer that. But it's very much about equity, I think, and trying to design a system which works for everyone's needs. And we're aware that not everyone has this at the forefront of their minds necessarily, but that shouldn't mean that they're then left behind. And so any system that we design, we still have to account for those people that might not take as active role in it.
Great, thank you very much, Scott. I think that's definitely a work in progress. So I suggest we move on to your next bit and then take more questions after that.
Yeah, sure. So I just wanted to pop this timeline up, which Mel actually presented a couple of weeks ago. And this kind of highlights the plan for trials which are happening within LEO over the next couple of years through to the end of the project. And actually this timeline is, this is from actually a few months ago before the COVID lockdown hit. So some of the dates might shift here. But we're kind of working on the MVS development and the MVS trials at the moment. And that's what I'm going to largely talk about next. But then we move into what we call MVS Plus, which is taking these small trials which focus just on particular assets and kind of framing that within the wider market that's being developed. So the different services which we mentioned earlier. And then we move into the trials which are actually part of the transition project, which goes on longer than LEO. And again, as we do that, each time we'll be broadening out the kind of the scope of those trials, but also the participants of those trials as well.
Oh, just could you go back again, because I think it might be worth, sorry, just pointing out to people that the bit in blue, the installation of network monitoring equipment, I was really surprised at how little real-time data the DNO actually gets. Yes,
at the lowest of voltages, yeah, there's kind of very little monitoring which is currently on the network, and because the network is essentially operated in one direction, that monitoring hasn't been necessary up until this point. And that's one of the big questions within LEO, is exactly what monitoring we actually need and where we need it, and we would like to have as much as we can, but that comes at a cost. So understanding that balance is kind of a critical question for LEO.
Thanks.
So we've stepped down a level in terms of MVSs. So now we're just within the MVS-A, which is around flexibility operation. We have these 5 different categories, which I mentioned earlier. The first kind of 2.5 is where we're working at the moment with the MVS trials. And so we use this prosumer, which we kind of define as having someone with a single flexible asset or site. And that can be co-located with perhaps some non-dispatchable generation, such as solar. Next, we have generation, and the difference here is that actually the generation itself is flexible. We then have smart neighborhoods, which we'll come on to in a second, but this is around multi-actor, multi-site coordination for local value. We then have aggregation, which is around the development of aggregator services in order to aggregate up smaller participants so that they can participate within these markets. And then finally, we have this portfolios, which is much more relevant to the later trials, which is about coordinating a diverse portfolio for network value and understanding how diverse that portfolio needs to be. So to jump into some of the trials that we've actually been running. So the first one is based at Oxford Bus Company. And to give a little bit of background, so Oxford Bus Company has a 140 kilowatt peak PV array, which is co-located with a 90 kilowatt hour battery. It has a supply connection capacity of 220 kVA and an export connection capacity of 143 kVA. And I mentioned earlier why, because we're limited at that capacity, this is actually one of the drivers for the bus company installing batteries. So it was initially to act as a buffer in order to charge electric buses, because their import capacity wouldn't have allowed that. And so that was one of the services that we'll be exploring with, is how you might be able to trade that capacity with someone at the same point of the network. So someone else might have spare capacity that they could trade to the bus company, for instance. Anyway, the aim of this was the very first trial that we ran as part of LEO, and really the main aim was actually just to test the service delivery procedure and the kind of the communications which have to happen between the different parties within LEO and within the market. And I think the bottom left picture is perhaps one of my favorite pictures of LEO so far. And that's Adriano on the phone to the manufacturer of the battery, because we quickly found out that the battery wasn't actually installed in order to deliver power back to the grid, because that wasn't the initial intent of that battery. And so even just to make that very first test, we had to overcome quite a few hurdles in order to get the battery connected in a way that would actually allow us to run these tests. So we looked at both the manual and remote dispatch of the assets once we had them operational. And we also wanted to start to think about what monitoring is required in order to validate a service had taken place. And so as part of this trial, SSEN installed some temporary monitoring equipment at the local substation. And we also installed some temporary monitoring equipment at the site as well. And then this allowed us to also understand the impact at the substation, which might be different to actually the service which you initially delivered. So here are kind of some of the results which came out of the very first initial trials, and on the left here is a power trace, and you can see that we have this shift of around the 30 kilowatts that we were expecting to see as part of the trial. And the high resolution monitoring that we had on site actually allows us to really accurately define when that service took place. What we see is after an hour, then at the end of that period, the power then returns to a much higher value than what we started with. And that's because the batteries were set to start charging after their discharge. So you immediately jump to a higher power than before. And what I want to highlight is on the graph on the right, this is essentially the exact same data, but it's aggregated up to your standard half-hourly energy meters, which you have on site. And you can already begin to see that it's much harder in order to define when that service took place. So I've added the purple bars just to show where we expected to have that battery. But if we're thinking about how you validate that service, well, if you look at the half an hour period before, it's actually slightly lower than the half hour period before that. So between 12:30 and 1, it's slightly lower than 12 and 12:30. And so is that an indication that it's already started, or is that actually just other things that were happening on the site? So perhaps people went for lunch and so there was a drop in demand, or something happened with the PV. So it's really important to understand what monitoring we require in order to accurately validate services have taken place. And I think this is a big question that we're trying to answer within LEO. And like I mentioned before, there's a real balance between kind of what we think we need, or having really high resolution monitoring, and then the cost of that in terms of data storage or the hardware itself. What we saw is for the service that we had here, we saw a 12p cost in energy, and that's essentially because we exported some energy which you get paid less for than the energy that you use. So when the batteries recharge, that costs slightly more than when we exported energy. But that's hugely dependent on the situation under which you operated that, as well as the baselining methodology as well. So whether we look against the previous half hour or what's happening with the solar, for instance. So kind of what moves on from there. So we're now looking at more permanent monitoring and how that can then be used to inform the bidding, as well as how you baseline. So how do you know what service was actually delivered? And we also want to understand exactly what the value was to the DNO or the DSO at the network level, because due to losses between the site and the actual substation, that won't necessarily be the same as what you see here. The next trial was based at Sanford Hydro. So this is a 440 kVA micro hydro, which was developed by the Low Carbon Hub. And this, you can see again, has a capacity which is slightly lower than what the total generation that you can get out of the hydro is. And the aim of this trial was to understand what short-term storage potential there's actually, that the river actually has. And that can be used for the peak management service that we mentioned earlier. Now, these first two trials were actually failure to deliver, and I think most of the people that have been working within LEO actually think that we understand more from having failed in these two trials, actually. So the first one failed because there was a sluice gate fault, and this raised questions around what happens when there is a failure to deliver, whether you need to notify the DSO, and also what penalty regimes might have to be put in place if someone doesn't deliver a service. The next one, again, was a failure to deliver, and that was due to the river conditions. So this was when the river levels were really high, and there was kind of risk of flooding earlier in the year. And this highlights a kind of need in order to better model what the river is and be able to forecast, which can then inform a certain time ahead within the bid process and notify of availability of the asset to be used for flexibility services. A successful trial was run a couple of weeks ago at Sanford Hydro, and we ran for about an hour. So we had full stop for an hour, and during that time we actually stored water within the river, and you can see that on the graph where the blue line drops low, and the green line, I think here, is tracking the river level, which you can see slowly increase. And then from 2 o'clock, we were able to run the hydro at much higher power, and so that could be used to peak shave. And so we're actually using energy which we'd stored up in the river. And so we want to continue these trials in order to feed into the system modelling we're doing around Sanford. The final set of trials that we've already run have been called Oxford Behind the Meter, and this is looking at coordination of multi-sites and multi-actors, and within the city of Oxford. And this is starting off with looking at HVAC within university buildings, but we want to extend this out to local authority buildings within the city as well. And so this is essentially using the thermal inertia which you have in buildings as storage. And here we're looking at the concept of virtual private wires between buildings, as well as peer-to-peer energy trading. So our first location was the Sackler Library in the centre of Oxford, and here we were using the fans. So HVAC is heating, ventilation and air conditioning. So we use the fans within the HVAC system to give us a turn up of demand of 20 kilowatts. And we actually introduced a new type of bidding for this trial as well, where we bid for availability of the asset as well as delivery of the service. But we had to postpone that due to problems with the communication system between the building and the central control. A couple of days later, we were able to manually run this trial, and it was successful, but it did have a delay. And going back to the monitoring at this site, we only had the standard half-hourly site monitoring. And on the graph on the left, the orange is what we expected and the blue is what we actually saw. And so you can see there's quite a difference between what we expected and what we saw, and it's quite hard to actually decouple the flexibility from the background building demand. And so this is kind of raising a lot of questions about how we need to monitor our assets going forward. Here we saw that it cost an extra £1.51 in terms of energy for the service that we delivered. So kind of moving around the lean ecosystem loop, we now get into kind of processes and KPIs, and one of the kind of important KPIs that we've developed is this concept of a process maturity stage. And so there's 5 different levels that we use at the moment. This is going from completely unknown, so we're not sure we know that a step does have to exist, but we don't know exactly what that step entails. The second level is a proxy. So we know what the step is, but for now we're just using a proxy service in its place. So you might have noticed that for many of these trials, we were just using a token £1 for the delivery of that service. Pardon?
A smarty.
Smarty. So as we develop more knowledge about what the business model is for these services, then we hope to increase the maturity of that step. We then have manual. So this is essentially when a human is involved in the delivery of that service. We have partial automation, and then we have full automation where essentially no human is involved in that process. There's a few other KPIs which we use both specifically within the MBSs and within Leo, which we measure our kind of progress against, and that informs the learning loops. So I've mentioned a lot of the learnings as we were going along, but they've revolved around service delivery processes, communication protocols between the different actors within the marketplace. A lot has focused on the appropriate monitoring that we need in order to run this market. We've done a lot of learning around data handling and how we process the data which comes in from these MVSs, and how you need to clean it, and how you use it in order to validate services. Again, we've started learning about settlement, and that's actually Brian from SSEN handing over the £1 to Adriano at the Low Carbon Hub for the Oxford Bus Company service. And finally, we've actually learned a hell of a lot from having a few failures as well. So I'll get told off if I don't mention the social learnings that we're also working and learning in. So we've done a lot of work in terms of stakeholder engagement and stakeholder mapping and the ethical framework for engaging with stakeholders. Understanding the relationships which are critical to the success of Leo is extremely important for replicability after the project. And also having a long-term engagement strategy with the different stakeholders that we're working with. We also use this idea of a business model canvas to identify new value opportunities within these different services which are being developed, as well as to track the success and failures of the ones that we've tested. And finally, there's a lot of learning to be done within the market design. So what are the new financial flows that didn't exist before this local energy market? And essentially, where does the money come from which actually pays for this delivery? So some of the ways that we've been adapting. So throughout the different trials, there's been a number of bug fixes on the different platforms. Data sharing and pre-processing, which I mentioned before, defining the dispatch message and the tolerances of the service, learning how we can remote dispatch certain assets, the bidding structure, so looking around energy or delivery or availability and the differences there, as well as developing a new delivery procedure for the different services as well. And again, around the protocols around what happens if an asset's not able to deliver. I got another slide for questions, but I've only got a couple of slides after this. I'll whiz through those and then we'll have some questions at the end.
Yeah, exactly. Thanks, Scott. Sorry, go on.
Yeah, no problem. So just to introduce a smart and fair neighbourhood. So this is very similar to the Oxford behind the meter that I spoke about earlier, but this is much more focused on within a domestic setting, but it's all about multi-actor, multi-site coordination for local value. And we're really trying to understand not just the physical infrastructure that needs to be in place, but also the social infrastructure that needs to be in place when you're dealing with a domestic level. We're working with catalysing local energy communities, which are closely aligned to the network trial areas, which Mel introduced a couple of weeks ago, which are the primary substations under which we aim to focus many of the trials. And we're also working a lot on identifying place-based value. So this is value for both the neighborhood and the network in that particular location, and that will change depending on the location and the different assets which exist within there, and also what kind of vision the local community has within those areas. And finally, energy equity is very much a priority of the Smart and Fair Neighbourhood trials. We also have aggregation services that we're hoping to develop over the next year, and this is largely being led by EDF and Nuvei through their EDS PowerShift program and Nuvei's vehicle to grid services. And this also deals with energy as a service integration. So how do you integrate that mobility and energy requirements? Finally, portfolios. So this is about coordinating a diverse asset portfolio for network value. And some of the kind of high level questions that we're starting to ask is, what diversity of service providers are required? How do you minimize non-delivery risk? What market dynamics enable best flexibility provision? So essentially, how do you convince people to actually take part in the market? And finally, the communication and response time for within the DSO enabled services. So if you have peer-to-peer energy trading, how do those two peers communicate, and how quickly do they need to communicate? We're almost there. So right up back to the top level. So we have these different types. I just wanted to mention the planning and policy regulation quickly. So we have this future system planning where we're developing an integrated land use map at the moment for Oxfordshire. And this is bringing in data sets which exist within the councils around future developments, as well as planning restrictions, which can be seen on the left, and putting that with network and PV generation possibilities within the county as well. So you can start to identify where is suitable for your generation, both on where we think we're able to maximize PV generation, but also siting it near where there's going to be future demand. And finally, the informing policy. So there's a diagram in the bottom left there, which is what Barbara was talking about earlier, where we've been working with Ensham and some of the new developments around Ensham, and this diagram is just highlighting the differences between a network area, which you see within orange, and the local district area or the parish area of Ensham. And that's feeding into some work that we're involved with, which is looking at kind of informing local policy around energy systems going forward. And that's everything.
That's brilliant. Thank you very much indeed, Scott. Got a couple of questions coming in. Just I hope people can bear with us before we will go off for supper. One question is, how extensive are the mathematical simulation models in Project Leo? I'm not sure I even know what that question means.
Yeah, so there's a few different levels of modelling which is going on. So I know the Low Carbon Hub are doing some modelling on their assets, and that's at perhaps a high level versus the academic modelling that's going on. But that's very much about identifying the business case for a battery and not overdoing it on the modelling. Whereas within the university, we're doing much more in-depth modelling of the energy system, as well as the assets themselves. So with the hydro, we would be looking at how you optimize the use of that river. So what time of day is it best to start backing up the river in order to increase your power later on to meet a particular peak, or how it might work versus local solar, which is on the same network node as a particular flexible asset. So there's a whole range of different modelling which is going on across the project.
And I think that links to Tom Broughton's question. Community energy groups need certainty of financial prospect to get investment. How can this be delivered in such a dynamic market?
Yeah, and that's a really good question, and I'm not sure I necessarily have an answer for that. And Barbara's the Low Carbon Hub really do operate in that place, and so I know how hard it can be. Again, I just kind of reiterate where we think that this agile approach can help. So while we're going through this transition, what we don't want to do is commit to a particular business model which in 2 or 3 years time will no longer stack up. And so that's why we're trying to kind of be agile and be diverse in the business models that we test, and see which ones are most successful as the system changes.
Yeah, I think it's a really interesting one that I think Tom has put his absolute finger on the nub of the issue there, because it's undoubtedly true for community energy that nothing is prospective at the moment is going to equal the certainty and simplicity in some ways of the fit-backed solar model, and maybe we can't expect it to. So I think we're going to have to watch this space, Tom, and there's a lot of work to be done on how all of this works. The contracts, you know, Scott's been talking to us today about the technical aspects of running these MVS systems. There's a whole question about how you contract between parties once those services are up and running, and over how long those contracts are signed. And one of the things that we know at the moment post-FIT is the power purchase agreement for new assets is absolutely crucial to being able to bring a project to financial close. So, you know, we've said in Project Leo that this is the first 3 years of a 10-year strategy for this country to work out how to do all of this, you know, and we're only just at the end of the first year of it. So watch this space, and maybe in 3 years' time we'll have another seminar when we've answered some of those questions. We've had Alan from Wantage saying that we should have water storage at Sanford Hydro with a floodplain next to it. I think people are very interested in the Sanford Hydro one, Scott, and how we persuade the Environment Agency to let us store water in order to run more through the peaks.
Yeah, and I think the restrictions are rightfully quite tight, but at the moment we're only making very small changes just to try to better understand the potential implications of doing that.
And we've got a land use question here from Councillor John Broad. How can you plan to use land that is presently attempting to be used for farming for food, housing, employment for PV farms, as well as greenbelt? And I think that's, I'm not going to ask you to answer that, Scott, because I think that's sort of slightly beyond your remit. But again, it's a really good question. And my response to that would be, firstly, that we know from the first real 10 years of working and operating and installing solar ground mount that there is best practice associated with those, where if you do it well, if you site them well on lesser grade agricultural land, you can be much more productive of biodiversity on those sites than if they were monoculture agriculture. But I would also say that if we get this transition right, if we get this smart local energy system right, we'll need less in order to achieve, less installation in order to achieve what we need to do. Third answer to that question is that we've done back of the fag packet, sorry, I'm not allowed to say that, what's the modern equivalent? I don't even know that we do right anymore. Anyway, we've done outline calculations of how much land area we'd need to take in Oxfordshire to achieve the targets that we've got, and it's a lot less than you'd think it is. It's you know, 1 or 2% of the land area. Finally, we'd love to do more rooftop solar, but getting owners to commit to a good 20 years of their roof not changing is quite a challenge. And the value that we can give back to them at the moment isn't persuasive. So if we can get these flexibility services up and running, then there'll be a better case and we can put more of that solar off the ground and on the roofs. I hope that's answered that question. I'm not seeing any more questions from anyone, Scott. So I think we're 5 minutes over, and I'm going to bring the webinar to a close. Thank all of our participants for their brilliant comments and questions, but thank you in particular, Scott, for such a clear explanation of all of those pioneering things that we're trying to do in LEO.
No problem, it was a pleasure.
Thank you. Have a good evening, everybody, and we hope to see you at the next webinar. Lots of thank yous coming up, Scott.
Just trying to scroll through all of the comments.
Yeah, I think we got all of them. I'm quite confident that, oh, we've suddenly got loads of Q&A coming in. Oh no, they're all the same people responding. So yeah, that's all fine. I think we've done it. Excellent.